Hello.
Now I request everyone to please take their seats, and I request all the volunteers, please call all the participants as we are going to start our next session. Hello, hello. Hello, hello, hello. Sir, good minute. Na na, kahile. Hello, hello, hello. ନାଇଁ ବହୁତ ଜୋରେ ହଉଛି ହଁ ହଉଛି ମୁଁ କହିଲା ବେଳକୁ ବହୁତ ଜୋରେ ସାଉଣ୍ଡ ହଉଛି ହ୍ୟାଲୋ 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 ଠିକ୍ ଅଛି ଆରେ ମୋ ଭଏସ୍ଟା ବଡ଼ ମୁଁ ଲାଉଡ଼ଲି କହିଲେ ସେଇଟା ଆଡ଼ଜଷ୍ଟ ହେଇଯିବ Moving forward with our next session, today we have with us Dr. Ramesh Kumar Sahu, who has been working as a faculty in IGIT Sarang since 2016. He did his PhD in the area of crowd sensing. He completed two sponsor research projects on the cognitive network and healthcare. He published two good numbers of SIC, Scopus journals and conference papers. He delivered talk on AI in healthcare, ALML using Python, scientific research skill using LaTeX in different university institutions such as Utkal University, IGIT Sarang, RIMIT, Anugul Creative Technology, Anugul, DAV Public School Dera, DAV Public School Kalinga, etc. His research focuses on crowd sensing, wireless sensing, cognitive science, sensor network, BCI, healthcare, and human activity recognition. With this, I call upon Dr. Sahu sir to come upon the dais and begin with our next session. Please, sir.
Good afternoon, everyone. Am I audible, I think? Am I audible? Now am I audible? Am I audible? Okay. Okay, so I am Ramesh Kumar Sahu. I am going to give a brief talk on Wi-Fi sensing, particularly because most of the talk is audible. Hello, hello. Keep it like this. Okay, now am I audible? Am I audible? It is okay. Okay, so particularly it is the afternoon time. Okay, so all of you just take your lunch and now you want to sleep. This is the fact. Clear? So particularly Wi-Fi sensing is the future because it reduces the need of high computing requirement. Clear? Most of the things, because this is not a new thing. It has been designed in 1865. Clear? But now it is increasing. Why? Because of the need of data. Clear? Because if you go for image processing or if you go for take the help of high quality images, then size of image is much more that. Clear? That you cannot accommodate because you have the limited amount of size. Clear? But as in the earlier time we have lots of size, data consumption is less, but now it is reverse one. Data consumption is more, but size is less. That's why we need a platform that can do the same work with minimal size, and for this reason Wi-Fi sensing is required. Clear? So particularly my Ajit sir and Shruti madam give you the all the details about Wi-Fi sensing. Clear? They have done their PhD, they give their 3 years of their life to this work. I just started the work, I give only 1 month. Clear? But they give their 3 years, so they know better than me. Clear? Particularly the theory part is covered, so I just give brief introduction about Wi-Fi sensing. After that, how the experiment will be going on, how you can, what are the software required, how you can set up the software. Clear? How you can set up the device with the software, how data can be recorded, how data can be saved in a CSV file, how it can be analyzed through graphical, how filtering can be done, how it can analyze through deep learning or CNN. That can I will visualize, I will give you the real time demonstration so that you can use it in your work. Clear? So it is a practical class, not a theory class. Clear? So whatever the doubt you have, just ask me at the same time. Don't keep in mind, so that I will ask at the end, but the end will never come. Clear? So because this is a practical class, so if you have any doubt regarding the practical, regarding how to install, how to use, just ask me at the same time, we will try to clear it. Clear? Slide changer. Okay. Not changing anything. Not with the first one. फर्स्ट को नहीं जा रहा है, प्रीवियस नहीं हो रहा है, हमेशा नेक्स्ट हो रहा है. Okay, so we start with the Wi-Fi sensing. Clear? So in my sense, particularly two keywords are there, Wi-Fi and sensing. Clear? Think about sensing. Sensing means what? Sensing the environment or detecting whether you have something in your surrounding or not, and what is the impact of that thing over the environment. That thing you can find out through sensing. Now sensing can be done with whom? With sensors. What do we need? We need a hardware device to sense the environment. Clear? So that hardware device need to be managed. If you implement a hardware device, that hardware device should require the power as well as frequent maintenance is required. Clear? As well as you have to reprocess the data. So complexity is more. Clear? So what we will do? We will try to eliminate the physical sensors. So in this case, Wi-Fi come forward. Wi-Fi means the electromagnetic wave that transmitted from transmitter to receiver. Clear? And using this electromagnetic wave, how we can find out the presence of any object or movement of any object, and this is called Wi-Fi sensing. I think it is clear? What is Wi-Fi sensing? Now this application of this Wi-Fi sensing can be broadly categorized into 4 different domains. First domain is called detection. Detection means find out whether any object is there in the environment or not. Clear? Whether it is available or not available. Available means true, not available means what? False. That's why it is called as binary classification. Its value will be either true or false. True means available, false means not available. And for these examples are like intruder detection. Someone is coming inside the room means what? It is present. Not coming means false. Clear? Fall detection, whether someone is fall down or not. Clear? So these are coming under this binary classification. Because suppose think about that, you want to identify an activity. What are the activity performed by an object inside a room or outside a wall? So that activity can vary from one to many. Clear? So different types of activities are there. So it cannot be categorized as true or false. What do we need? We need multiple classes, multiple categories, and this is called multi-class classification. Clear? Or it is known as recognition. Means what? We want to recognize the activity. Clear? Recognition means we want to recognize the activity. How? Recognize the activity of object or the human. What the human is doing? Whether he is gossiping, whether he is fighting, whether he is sitting side in idle state, whether he is standing, whether he is climbing, whether he is clapping or hand, what he is doing, what that is need to be identified or recognized. This is called recognition, and this is coming under multi-class classification. Clear? Multi-class classification, and examples are your recognition of gesture, recognition of activity of movement, recognition of various activities done by your object. Clear? Next part is your localization. Next part is localization means what? Whether the object or the thing is moving or not. Clear? And if it is moving, what is the current position of the object? Where is my object? Just like where is my car? Where that person belongs. Clear? What is the current position of my particular person in this college? That is called localization. Localization or tracking. That can be done through this Wi-Fi sensing. Clear? Next is your estimation. Estimation means finding out the value. Value means what? Value, it will be either the size, it will be either the angle, it will be either your destination or anything like what is my breathing rate, what is my diabetic level, what is the temperature of this room, what is the humidity of this room. This is called quantitative value. So those quantitative value also you can find out by observing the electromagnetic wave of the signal. Those are coming under estimation. So particularly by analyzing the electromagnetic wave that is moving inside a room or outside the wall. By analyzing this, we can detect the object and their activity, and this concept is called Wi-Fi sensing. Clear? And to make it possible, what are the technology required? First we can do it using Wi-Fi. Particularly it is based on Wi-Fi. Why? Because range of Wi-Fi is more. It is what? 50 meter. So you can cover a large area. That's why particularly Wi-Fi is used. But suppose the room is very small. You can go Bluetooth or low energy. Suppose it is in the 10 meter radius only. So you can go for Bluetooth. Suppose it is in the centimeter. In that case you can go for near field communication. This simple example, suppose you think about that, you have used a phone copier or clone phone. I think you have used. If you want to buy a new phone, you will go to the market, they use a software called clone phone. It is based on this NFC or near field communication. Clear? So in that case, it depends on the distance between sender and receiver, and as per that you have to think about different technology that you can use for Wi-Fi sensing. Clear? It can be either Bluetooth or Wi-Fi or RFID or radio frequency identification, like that. Clear? Now what are the stages we have? Two stages particularly we have. I just give a brief idea, so that the thing that is described by sir and ma'am in the morning sessions can be reback to you. Clear? So you can better understand it. So your that Wi-Fi sensing can be done in two stages. First is what? Pre-processing. Next one is higher order processing. Pre-processing means it is used to highlight or identify any large activity. Clear? Suppose you want to find whether a person is fall down or not, whether a person is entered the room or not, whether fan is moving or not, whether light is turned on or turned off. So that kind of thing you can observe through by analysis of any sensor. It is what? This is called pre-processing. Means what? You can use any filter, you can analyze this with CSI data through the filter, you can observe the pattern. From the pattern, whether you can find out whether that thing is present or absent. This is called pre-processing. But suppose you want to observe a micro activity. Suppose what is the diabetic level of a person. To find out that, what you need? You need a blood smear, then you can find out. But the same thing you can find out through Wi-Fi sensing, because whenever the Wi-Fi signal transmit within you, clear? So that particle within you will provide a impact on that electromagnetic wave, and from that you can find out their diabetic level. But it needs thousands of observation. Clear? And for this case, what you need? You need analysis of CSI data through high-end technology, particularly called AI or deep learning or machine learning. This is called high order processing. Clear? So in that case, so these two mechanisms are there through which you can analyze your CSI data. Clear? Now just give a brief comparison between existing technology and the Wi-Fi sensing. Suppose that person is walking. Clear? Now it can be identified through vision based technology. So you can use the camera over there. From the camera you can record the video or you can take a picture. After that, that thing will be saved as a image file that takes lots of data. After that, you have to analyze it. In that case, high performance computing is required. Clear? After that, it has been trained or analyzed through CNN or machine learning. Then you will get your result. So in that case, high performance computing is required. Overhead is more in both the cases, computation as well as cost, because you have to implement a high resolution camera, then you have to use large amount of data center, then you can go for the computation using high performance computing. So cost is more, overhead is more. The same thing can be done through Wi-Fi sensing in lost case manner. How? You can simply use a Wi-Fi router. Clear? So that Wi-Fi router will detect the activity and save it in a what? In a text file whose size is in KB, not in MB. Size of image is what? 10 MB, but size of CSV file is 10 KB or less than that. Yeah, same thing you are doing, but instead of image you are taking data through CSV, so your size is less. Clear? So same thing we are recording. Now this data is going to pre-processing to find out the pattern. After that, we extract the various features from here. Now using this feature, you apply machine learning or deep learning algorithm, then find out the same result. Clear? So two mechanisms we have. If you go for Wi-Fi sensing, it is cost effective because we don't need any other devices. We don't need high performance computing. We don't need sensors. We don't need camera. Clear? So computational overhead is minimized. Clear? Next is what? Cost is also minimized because it is device free. Clear? So the limitation of existing technology can be reduced by Wi-Fi sensing, and for this reason Wi-Fi sensing is the future, and for this reason you must know what is Wi-Fi sensing, how to use it for your work. Clear? So give your attention, clear, and try to learn it. Particularly I focus on the practical, not on the theory. Clear? Next is the foundation of Wi-Fi sensing is CSI or channel state information. In my case, channel state information is nothing but a properties of the channel through which data will pass from transmitter to receiver, or you can think about the electromagnetic wave that is moving from transmitter to receiver. That wave is your CSI. Clear? So this is a mechanism that controls how the wave will move from transmitter to receiver, and if it interacts with any other object available in that room, available in that location, then what is the impact of that object over the signal? Clear? Over the CSI. So this mechanism is controlled by CSI, and if we try to make a relationship between CSI data and the thing available in the room, we can find out the various features and you can detect the object. Clear? So this mechanism is generally used and it is implemented through CSI. Clear? So it has 64 carriers are there. It is divided into 3 types: null carrier, then your pilot carrier or data carrier. Data carrier means the data that is sent from transmitter to receiver is available inside the data carrier. Clear? Pilot carrier is used to estimate the channel. Channel properties is defined inside pilot carrier. Next is what? Null carrier. It is a reserved thing. It is used for special purpose. Clear? If you want to give some special data, in that case you can use it for your work. This is called null carrier or reserved carrier. Clear? Now this CSI is based on 2 models. First is called ray tracing model. This model is used to analyze a situation in which transmitter receiver are placed inside a single room. We don't have multiple rooms. In a single room we place the transmitter as well as receiver. Clear? Both can observe each other. This is called line of sight interaction. So just observe this graph in which we have a transmitter here, we have a receiver here. Your electromagnetic wave can be passed from path 1. This is called LOS or line of sight path. In this case we don't have any obstacle here. Clear? So amplitude will be more. It is clear? So if there is no obstacle at all, this is my original signal. Clear? This is my original signal. Since there are no obstacle, so obstacle is same as the received one. Clear? But suppose the transmitter is moving from the upward ceiling. Now that signal is reflected from upward ceiling to that receiver, and due to this reflection some signals are attenuated. Clear? So amplitude will change. Clear? So the same thing that you observe through this, the same figure, the same curve you can observe as a dotted line. Clear? So in this case just think about that. In line of sight path, amplitude is more. What is the amplitude? This is your amplitude. This amplitude is more. But in case of reflection, in dotted graph, this amplitude is less. But suppose there is an object through which electromagnetic signal will pass. In that case, due to this, that electromagnetic wave will move through the object, and doing that refraction will be done. Clear? Then first refraction, then deflection, then come back. Clear? So it is observed through this small line. So in that case amplitude is reduces. Clear? So data can be passed directly without any disturbance, or can be passed through reflection, or can be passed through a object. Clear? In both the cases some changes are made within the electromagnetic wave, and that changes has been observed through CSI data. If you properly analyze it, you can find out the object that put impact on the electromagnetic wave, and you can detect it. Clear? This is called ray tracing model. So in this case the receiver and transmitter are available inside a room. Clear? Not outside. It is available inside a room. But suppose the situation in which you have to sense outside the room, where transmitter and receiver are placed inside a room, but that thing is going on outside the room. Clear? So in that case, what? We don't have any routers here, or we don't have any transmitter receiver is there. All the things are there inside a room, but you want to observe the thing going on outside it. How? Do this electromagnetic wave, because Wi-Fi signals can go beyond this room. If it can go, then after whatever going on outside the room can be observed and can be bounced back to receiver. Now from that you can find out what happens there outside the room, and this is called scattering model. And for this model, what you need? You need deep learning or machine learning. Clear? Are it is clear? Just like that. In this graph, if someone is walking, clear? So graph will be like that. But suddenly if it fall down, then amplitude will increase. Clear? Now experimental setup of Wi-Fi. Now we will come back to our main agenda. We have to set up the environment so that you can work. Now this is the setup. In this three stages we have: input, processing and the application. Input means set up the hardware, set up the software. So in that case, two things we have a transmitter as well as receiver that will be placed, and data will be sent from transmitter to receiver, and whatever the thing going on, that will be recorded through CSI. This is my input. After that, that input will be given through pre-processing. After that, it will be analyzed through machine learning or deep learning. Then it can be done through detection, recognition, localization or estimation. Clear? Now to do this, what you need, particularly what are the hardware requirement and what are the software requirement. You can do this, but cost is very less. What you need? You need only ESP32 microcontroller, and its price is 300 to 400, not more than that. You will get it in the market. Its price is only 300 to 400. It is simple microcontroller. It has 32 pins. 30 pins it has. It is works on the Bluetooth as well as Wi-Fi. Through this, any network based applications you can deploy over this microcontroller. Then microcontroller will run this application and observe the environment. So this microcontroller can act as a receiver as well as sender or transmitter. Clear? After that, you need a software. Two software is need. First is what? Emulator. Through the emulator, this is called ESP-IDF emulator. Through this emulator, you will design the application. You will compile the application. You will build the application. After that, using emulator, you can put this application inside a microcontroller. Then microcontroller can run. Clear? So ESP-IDF is the emulator that you should know and that you should install first. Then only you can go to this programming. Clear? Next is what? ESP32 CSI toolkit. Clear? This also a software that has been designed for specifically collect the CSI data or inform the environment. Clear? So you have to install these two software. After that, set up the hardware, then you can start your work. So we will discuss about how to install these two software. Clear? Next is ESP-IDF. ESP-IDF is a simple software that has some application programming interfaces through which you can design any kind of ESP based application to observe the environment. Clear? It has also two requirements, hardware as well as software. Clear? In the case hardware, what you need? You need a ESP32 microcontroller. Then you need a serial cable that connect 32 microcontroller to your laptop. Clear? Then you need a computer that is powered with either Windows or Linux or Mac. So ESP-IDF is a cross-platform software that can work with any kind of application, any kind of OS. You can use MacBook, you can use OS, you can use Linux or you can use Windows. So three things you need: a laptop, then a serial cable and a ESP32 microcontroller. Clear? Then software requirement, what you need? You need a ESP-IDF software. Inside that you need a tool chain. Tool chain is used to compile the program. Clear? Tool chain is the compiler. Clear? Now what you need? Build tools like ICMIB and Ninja. Those are used to, after compiling the code, those are used to integrate the application so that the final applications can be developed for the hardware. then you need a SPIDF that provides the API to write the application. It is based on nested C, clear, because C programming is used, that is C is a low level programming language. To have any application that you want to develop for the hardware, you have to go through C, clear. So in that case also nested C is used, clear. Now how to set up the environment? It has 4 stages. In the first stage, what are the initial requirement to run the SPIDF that you have to give? This is your initial install P request. Then next step is get SPIDF, download SPIDF from the internet. Next step is set up the tools, means install the SPIDF, clear. And fourth one is set up the environment variable or set up the environment in which SPIDF will work, clear. After that, first one, three operating systems are there, we will discuss it one by one, clear. First is Windows. Windows is much more easy, you have to do nothing, just go to the SPIDF site, I have given the link, there you will get the offline installer, download the offline installer, then install it, clear. So this software installer, this installer automatically download the P request file, automatically install your application, automatically set your environment. So all the 4 steps, step 1 to step 4 will be done automatically by this software. You don't need to do anything. You just need to click on next and next. Finally your software will be installed. That's why Windows is much more easy, clear. After that, if you want to use Linux, so in that case you can need various softwares like GIT, CMAC, Python 3, your LIBSB, like that you have to install first. So simply copy the command, paste it on the terminal, all the software will be installed. Similarly do it for MacBook. Similarly for if you want to download, after P request go to the downloading stage, clear. In the Windows I just give you the link, from that you can download the file. But suppose if you are using Linux or Mac, so you have to use this command, clear. Going to go to the site, just copy the command, paste it on the terminal, automatically software will be downloaded, clear. So first is what? mkdir -p esp, you will create a folder esp. After that change directory, next is git command, will download the software from that website and save it in your esp folder, clear. Similarly same thing you can do using the Mac. Next is set up the tools, clear. In Windows simply install the application. In case of your Linux and Mac, first of all go inside SPIDF, after that simply write /install, clear. This command will install your application, clear. In case of Windows you have to click it, but in case of Linux or Mac you have to write the command, clear. That command I have already given, simply copy and paste, that command will download software, install it in your Linux or Mac. After that set up the environment variable, clear. So in case of Windows you don't need to do anything, all the tasks will be done by installer itself. Installer will create a desktop file, after installation you will create a shortcut that is available inside your desktop, click on it, your application will be started. But in case of Linux or Mac you have to create the own shortcut, and that part you should do through bashrc. So open the bashrc, now copy and paste the given command to the bashrc, now save the bashrc through the source, now write get _ command, this will open your application in case of Linux and MacBook, clear. Next is how to build the project using SPIDF. Six stages are there to build any application. First of all start the project. How? Simply click on the desktop shortcut available in the Windows, your application will be started. After that go to the project or project folder, clear. After that next is configure the environment, clear. What are the baud rate, what are the devices you need, that you should be configured. After that build the project, means what? Compile the project and make it integration, so that the application will be built. Then flash onto the device, clear. Write the application to the ESP32 microcontroller. After that observe the output. Step 6 is observing the output. Now the thing is that how to go these 6 steps. If you go for step 1, in Windows very simple, in Linux very simple. In Windows you have a shortcut file in the desktop. I will display in the computer. I have already installed a software. Clear? There is desktop, you have a shortcut, click on it, USB IDF will be running. Clear? After that, change the directory to the project. Clear? In Windows. If you go for Linux, open the terminal, then write get underscore IDF. Your application will be started. After that, go to the project. Clear? So, in case of Windows, you have to click it, but in case of Linux or Mac, you have to write the command get underscore IDF. Clear? In case of step 2, connect your device with the laptop. Clear? What you need? You need a microcontroller, you need a serial cable. 2 ends you have, connect the device with your laptop. After connecting, you get a port number. In case of Windows, it is like COM1. In case of Linux, it will be like /DAB TTY or /DAB USB 0. But in case of MacBook, it will be like /DAB CU. Different things there, but the thing is same. You need a serial port through the data communication can be made. Clear? From microcontroller to clear. That serial port is the component. After connecting device to laptop, you will get this. How to configure? Simply write idf.py